Welcome back, Math 10, and welcome to your first lesson on radicals. So to start off, we're just going to do some definitions here. So I take a look. The x inside there is called the radicand, this green guy. The next one, that n, is going to be my order of the index. My last one, that blue little symbol, is called my radical sign. All right, that there is the radical sign. Okay? So now that we know my definitions, which are important to know, we're going to start with some examples. So here we go. Let's warm up just before we go swimming. So 4 multiplied by 4 is 16. So the square root of 16 is 4. Or we could write it as square root 16 is equal to 4. Okay? The next one here says 5 multiplied by 5 multiplied by 5 is 25. So the cube root of 125 is 5. And the cube root, again, you write it in that form, is going to be 5. Okay? Let's take a look at the next one here. We have 2 times 2 times 2 times 2 is 16. So the fourth root of 16 is 2, right? Because there's 4 2's multiplied together. Fourth root of 16 is 2. That's just another way of writing it. There we go. Now that we've warmed up a bit, let's test the waters and try these guys here. Okay? So it says, what are these answers? So we have square root of 49. Let's do this mentally. Well, 7 multiplied by 7 is 49, so square root of 49 must be 7. So take a look. There it is. Next one is the cube root of negative 64. Wait a minute. That's negative. But it is the cube root, not square root. It's an odd number. The radicand here, or the index, is an odd number. So therefore, we could do a negative. So I look at that. That's going to be 4 multiplied by 4 multiplied by 4 is 64. So it must be negative 4. There's my answer. The next one here says the fourth root of 10,000. Well, look at this. I have 4 zeros. So that's 10 times 10 times 10 times 10 times 10. 4 tens. There we go. 10. Now let's take a look at D. Oh, fifth root of 1 over 32. Well, 32 is 2 times 2 times 2, 5 times. So then 1 over 32 is going to be 1 over 2 multiplied by 1 over 32, or 1 over 2 multiplied by 1 over 2 multiplied by 1 over 2. So my answer is 1 over 2. Now my next one, the square root of negative 16. Well, I look at it, or the fourth root, it could be 4. Now, or it could be 2. So negative 2 times negative 2 is positive 2. Times negative 2 is negative 8. Times negative 2 is positive 16. So this can't be. This is impossible. Let's take a look at my last one here. Okay? We have, well, the cube root of 125 is 5. Multiplied by 2, I'm going to get 10. And there we go. So now, we're going to take a look at this one here. All right? So, try and solve for x in this one. Well, how do I solve for x? I have a hint for you. First, what do we want to do? We need to make them the same base. So the base is 4, 2, and 4. They want to be in the same base. Then, once they're in the same base, it's a little bit easier. Now we have the same base. What must be true about one part must be true for the other, because they must be equal. So here's an example of how we could do this. Let's take a look here. So here we go. I want the same base. 2 to the power of 1 is equal to 2 squared x. So this is like saying 2 to the power of 1 must be equal to 2 to the 2x. So in order for these to be the same, my powers must be equal. Because if I look at this, 2 to the power of 1 is 2. So these are the same, so how many times 2 must be multiplied together must be the same in order for it to be the same. So I have 1 is equal to 2x. Okay? So x is equal to, divide both sides by 2, right? Divide by 2, divide by 2, 1 over 2. And we're done. Okay, now let's go back and see what else we have here in the store. Now we have some other ones to munch on. And we're going to have to use our calculators for these. So let's look at our calculator and use that for these. So the first one is 1 over or the fifth root of 1024. So how do I punch this into my calculator? I'm going to do it this way. I'm going to have 1024 all to the power of 1 over 5. Okay, this pretty much means 1 over 5. So let's plug that in. Look here, I'm going to have 1024 to the power of bracket 1 divided by 5. And I get 4. See how that works? It's going to give me 4. Negative. Can this one work? Yes, because it's an odd. My index is odd. So let's try this one here. I want negative, clear, put it in my brackets, negative 2187 all to the power of bracket 1 divided by 7, which gives me negative 3. Now my next one, negative 3 multiplied by whatever that is. So we're going to punch that in first. Do my exponents first, because of bed maths, brackets, exponents, right? Exponents is first. This is technically an exponent how we write it. So we have 50625 all to the power of bracket 1 divided by 4, or 0.25, which gives me 15. 15 times 3 is negative 45. Okay? Now, how about this one here? So we have 216 divided by 125. So we'll go and go 216 divided by 125. Enter. And all of that to the power of bracket 1 divided by 3. And I'm going to get 1.2, put my answer in a fraction. I get 6 over 5. Now, why do I use these exponential forms like that? Because if we go back to our last one here, we found out that 2 is equal to 2 to the, or 4 to the 1 over 2. So 1 over 2 is the same thing as saying square root of 4. Okay? So we could put, because remember there's an imaginary 2 there, so we could put these, those are equivalent. So that's why these fraction things kind of work. We'll explore that a little bit more. So now here's another brain teaser for you. How do I do this one? When I look at this, this is 27 squared. So I'm going to do that first. So I'm going to go 27 to the power of 2. Enter. And then I want to cube root that. So I now know I want the cube root of 729. So I cube root that. And I'm going to end up getting 9. So really, I wonder if this is the same thing as doing something like this. Okay, 7 to 9 to the power, 27 to the power of bracket 2 divided by 3. Look at that. Isn't that interesting? I wonder why that worked. If you could tell me why, good job. Now let's try my last one. I'm going to have to pull that out in here so we can see it. It looks, like this. So we have 2 multiplied by 4th root of 18 to the 5. Well, let's take a look at that. So first I'm going to go this all to the power of 5. That's going to give me a big number, isn't it? So this is the same thing as 2 multiplied by 18 to the 4 over 5. So let's plug that in. So 1/8 to the power of bracket 4 divided by 5. This is the other way around, sorry, it's 5 over 4, because we have to put this to the power of 5. So to the power of 5, enter. And then we want to 4th root it. So we're going to go, that to the power of bracket 1 divided by 4. And I'm going to get 37.075. I'm going to multiply that by 2. It's going to give me 74.15. Okay? Identify the index radicand of each of the following. So where is my index? Where's my radicand? Well, here's my radicand. And this is my index. This next one right here, 2 is my index. Radicand is 50. Now let's look at this one here. 3 is my index. radicand is 1 over 10, negative. Okay? So now it says to state whether the following is true or false. Well, I look at this here. We could test in my calculator. Let's try it out. So we have square root 3 multiplied by the second square root of 6. And I get 4.42. Well, what is the square root of 18? 4.42. So that is true. Well, that's interesting. Let's try this one here. If we plug this in our calculator, let's see if that's true. So we're going to have square root 20. We're going to divide that by, well, let's pretend this is 30. Sorry, I'm going to change that to 30 to make more sense. I'm going to divide that by, and I'm going to get 1.4. What is the second square root of 2? We get 1.4. So this is true as well, which is very interesting. Now let's try this one here. So this is really the square root of 25. Gives me that, 5. Well, what is the square root of 16 is equal to 4. Square root of this is equal to 3. This gives me 7. And this is 5. So these are not equal, so this is false. Well, that's interesting. So if I look at it, when I multiply and I divide, I could just divide the fraction side, or I could separate into multiplication and division. But adding and subtracting, I cannot do. So what do we know about exponents? So if we remember way back to grade 9, there was a rule for multiplying with exponents. What do we need to have? Well, we needed to have common bases to multiply with exponents. Also, if we take a look at things like this, if I said 2 multiplied by 3, I can multiply those, because what are my exponents? They're the same. What about 5 multiplied by 8? My exponents here are the same. That's equal to 40 to the 1. So as long as I have the same exponents, I can multiply the bases together. Okay? If I have the same bases, I added exponents. Okay? Now what about adding and subtracting exponents? Okay? What about that one there? What rules can be made for adding and subtracting, if we remember from before? Well, we cannot add or subtract. If I remember, if I added or subtracted, so if I look at the subtracting, well, what did we know? We couldn't ever add or subtract with exponents, could we? Even if they had the same basis, we couldn't add or subtract. They were different. Now, let's just go over these and try and help us with these ones here. So it says, write the following as a single radical. Well, it's the same as square root of 24. Write this one. Well, this is, write the following as a single radical. What's this one? This is square root of 21. Okay, so we could just multiply those together. This one here is going to be square root of 50 divided by 10, which is square root of 5. Now the next one here, oh, that looks different. So we want square root of a number. So, oh, I think it wants all of this under the square root there. So what is the square root of 100? We have 10. Now, what is the square root of 2? Square root of 2. Now, can we simplify this? Yes. This is the same thing as square root of 10 divided by 5, or 2, which is equal to square root of 5. There we go. Now, my last ones express each as a product. So now we're expanding everything. Okay, so this is going to be square root of 7 multiplied by square root of 11. That's the only one I can think of. Next one here, 27. Well, I know 3 times 9, so that's square root of 3 multiplied by square root of 9, which is the same thing as 3 square root 9, or square root 3. The square root of 9 is equal to 3. Okay? Let's try 40. Well, that's the same thing as 4 multiplied by square root 10. Square root 4 multiplied by square root 10. This is the same as 2, so I end up getting 2 square root 10. And that's it. Alright? So hopefully you understood everything. good luck. As I see you tomorrow, we work on these together.